Hey coding buds. So basically today's GFG POTD we have a problem count pairs sums in matrix, and basically it is a easy load problem, and the problem statement is given two matrices mat1 and mat2 of size n cross n. That means it is a square matrix, and it is given as where the elements in each matrix are arranged in strictly ascending order. Okay, that means every element in every row is like sorted in sorted manner. Okay, especially each row is sorted from left to right, and the last element of row is smaller than the first element of the next row. You are given a target value x. Your task is to find and count all the pairs A, B such that A is from matrix A and B is from matrix B, where the sum of A and B is like equal to x. Okay, so basically in the given problem, we have two matrices of n cross n size. That means both are like square matrix, and they all are like arranged in sorted fashion. Okay, or we can say ascending order, and the elements are like sorted. Okay, in each particular rows. Okay, and here we have to like return the total number of pairs or total count of pairs, where if we are actually adding each element from, let's say, matrix 1 and the other elements of matrix 2, and if we like adding those two elements, if it is like equal to x, that means here we have also a value x. Okay, if they are equal, then there we have to find the total number of pairs. Okay, so here these are the example here. Like if I'm talking about the example one, here we have a n is equal to 3. That means n cross n, that means here we have a matrix of n 3 cross 3. That means 3 rows and 3 columns. Okay, for matrix 1, and similarly for matrix 2. And as we can see, the elements are like already sorted here: 1 5 6, then 8 10 11, and then 15 16 18, like that. Okay, and here the pairs whose sum is found to be 21 are like 120, 5 16, 8 13, and 11 10. So if we are like adding these numbers, we are actually getting like 21, which is our x value. So here we have to find the total number of pairs. So here we are actually getting 4. Okay, and this is like asked in fact set, and here we have to solve this problem with an expected time complexity of order of n square and expected overall space of order of 1. So basically, if I'm talking about the brute force approach, what we can do, as I have like solved the problems, I think yesterday or the day before yesterday, there was a problem which is based on a matrix, and I have like what I've done, I have just converted my 2D array or just simply matrix into 1D vector, and then I have just simply search all those elements like in the previous problem. But in today's problem, if I'm talking about the brute force approach for this problem also, so what I can do, for the first thing, I have to create one vector, let's say v1, where I have to just insert all those elements of my matrix 1 of elements into that vector. Okay, that means v1 vector, and similarly we have to do with the matrix 2. Okay, for the v2 vector, once I've inserted all the elements of matrix 1 into v1 vector and matrix 2 elements into v2 vectors, we can simply check by using for loop. Let's say for int is equal to 0 is less than v1 dot size, and and let's say j is equal to j is like j is less than v2 dot size. Then we can simply add like matrix of I v1 of I plus v2 of j is equal to, if my value is x, then there we can simply make our count plus plus. Okay, but I think it will make our time limit exceed. It may give some types of things. Okay, because we actually doing this from, because the brute force approach is like having a lot of time complexities, or we can simply say that it is like 3 times order of n square, which is like not good. Okay, so what we have to do in the given problem here, I'm going to solve this problem by using sets. Okay, so first of all I have to define here unordered set. Okay, and for solving this one with an expected time complexity of order of n square. Okay, and expected auxiliary space of order of 1. Okay, so here we have an unordered set, and here we have to define it in the form of int. Okay, as we have to store integer type of data. Let's say here just declared with data type. Okay, not data type but the data variable. Okay, for the set. Now here what we will do, here first of all I have to traverse inside my matrix 2 and take all those elements, just the same concept as the previous one. There we have like used for vector, here I'm just using set for inserting all those elements. Okay, I is less than matrix 2 of size for the row. Okay, and then I plus plus, then after that here we have to simply do what, for int j is equal to 0, and then j is less than like matrix 2 of 0. dot size, that means for traversing inside the column. Okay, and then j plus plus. Now here what we have to do, here we have to insert all the elements inside the set. So for inserting, what we'll do, here we have our set name is data dot insert is a method, and what we have to insert all those elements of matrix 2, that means matrix 2 of I and j. Okay, like once we have inserted those things, now we actually getting all these our data which is like in the matrix form. Okay, especially I'm talking about matrix 2. Okay, so these are all other data I have arranged in the form of sets, and we know very well about set. A set is a well-defined collections of object. Like repetition is not allowed in set, and we know very well about these things. Okay, so while using set here, our like data are in the proper sorted fashions, and duplicate is not there. Okay, if there is something, then duplicate will be not there. Okay, now once I like done these things, now in the second traversal, here also we have to do second time traversal, but the thing is that while traversing our first matrix, here we have to also apply the conditions. Okay, through which we can get the output here. So what we can do here, we can do for int I is equal to 0, and here we have to insert, here we have to like we can say that here we have to traverse inside the matrix 1. Okay, so int I is equal to 0 and I is less than like matrix 1 of size for traversing inside the row, and then I plus plus, and then after that what we will do, here we have to again for int j is equal to 0, and then after j is less than matrix 1 of size, that means for traversing inside the column, and then after that we have to do j plus plus. Now along with that we have to, here we have to check the condition here. Okay, so what I can do here, I have like defined for matrix 1. Okay, so now you have to just check. So here just declaring one variable, let's say check, and inside check what I'm doing, whatever is our required target value, that means x. Okay, here to just simply subtract it, then like we can say that matrix of 2 of, or no, 1 of I and j. Okay, we can simply subtract all those values. Okay, and then after that we can check our final condition. Okay, so what we can do here, we have to check for the final condition. So what I can do here, we have to just simply check if what we can do, if our data dot find. Okay, data is our set and find is actually a method, and it is having check value. Okay, and if it is like not equal to, we can say that if it is like not equal to, we can say that if data dot find of check is not equal to matrix of, it's not equal to our target value. So here what we will do, if data dot find, actually we are checking here or check data, which is like this way. If it is like not equal to x, then here what we will do, here we have to simply first of all we have to declare one count pairs. Okay, so here we can declare int count pairs. Okay, so here it will like total count or like count pairs is equal to 0. Okay, and here we can just simply make an increment of count pairs. Okay, count pairs, then plus plus, and then we have to just simply return these things. Okay, let me do these things, count pairs. Okay, let me compile and run. Okay, so here what I have to do here, if my data dot find check is like equal to matrix of 1 of I and j. Okay, actually I'm checking with the elements target value. Okay, so let's try to compile and run again. Data dot find method, and here what we will actually check, okay, what we have to do here, where we have to do data dot find, here to check method, and then it is like not equal to data dot end. is actually also a method. Okay, inside the set, let me try to compile it again. Then after that we have to do count plus. So it's here, compilation is completed. Let's try to submit it. So it's submitted. So that's all for today. Thanks for watching.